Okay. So girls, that that's the one I just showed you. Did you see the video? Oh my gosh. Where? Let me see if I can find it. It's in downloads. Like after like it's a wonderful life. That's so cute. That's my friend who got a panda sweater for her Boston Terrier. Sorry you missed that. Okay. So, okay, girls. And then some of y'all are having the discussion with me or with other people right now about which AP you're going to take next year. But if you take BC, or I continue to say, if you take AB, most of y'all with your math ability will end up in Cal 2 one way or the other, whether it's in college or here. And you'll study sequences and series on a grander level. It's really a lot of fun. I'll show you a super cool series today. But we have to spend a fair amount of time brainstorming about can I write the pattern for the series, because I need the pattern for the series to be able to do something with it. There's all sorts of series around that people have to deal with, like you may have heard of Fourier series. I mean, they really have some pretty strong real-life applications, but this is the foundation for it. It's not that you need to learn the big, horrible, bad ones right now. You got to start somewhere, so you'll learn some arithmetic, some geometric, and like I wrote down the other day, there's arithmetic when you're adding. There's geometric when you're multiplying. And then there's a lot of things that are neither. And that's a huge category. That's fine. It's just like when you study functions that are even or odd, it makes my life easier. I know about their symmetry. But tons of functions are neither. So there's nothing wrong with that. It's just if there's something special about them you want to know. But we tackle a lot of things that are not arithmetic or geometric. Arithmetic means you're adding the same number every time. Geometric means you're multiplying by the same number every time. I would think that my wonderful pre-cal teacher, Miss White, she didn't really want to give up. Well, maybe she just didn't do it because of, I don't know what reason, but she didn't really give us handles to write our series or sequences from, like a pattern for it, like I tried to give you the other day. So I went home and or it's also in books and stuff, but I went home and thought, how am I going to get this right? Which is sort of what I told y'all about the other day. If you're adding by the same number every time, and in retrospect, after I show you what I'm doing today, she did tell us. It's just that I wasn't cluing in what the purpose was. Because once you start teaching arithmetic series, you start to see a 2n and a 3n in your formula. And I was probably supposed to pick that up. Once you start seeing geometric, you're multiplying by 2 times 2 times 2 times 2. So like one of you said, you see the 2 to the n and 3 to the n power. So my guess is I was supposed to pick that up, okay? You see alternating and everything. But I want to just start with y'all on the front end of just some techniques that you can start with. And then some things that you probably wouldn't have recognized, unless you saw Miss Arcan, you noticed this quadratic right away. Some of you did. I didn't know that myself until later. But there are certain things that you can do. So let me just talk about the certain things, and I'll take certain questions. But this would have been very helpful had someone told me this. So here you go. If you find something that's alternating, use a -1 to some power. If I have -1 to the n, if I have -1, you have to look at where n starts. That's really important. Always make sure you know where n starts. That's super duper important, okay? And you have to engineer it or manufacture or rig it up to where you want it to start with a positive or a negative. That can be easily changed by changing your exponent to n plus 1 or n minus 1. It actually doesn't matter which one you do, okay? So Lindsay might decide to make hers alternate with a -1 to the n plus 1. Pietro might use a -1 to the n minus 1. It's not going to matter, because if n is 3, this number is going to be negative 1 to the fourth. Will be a positive. What will this number be? Negative 1 to the second, which is also going to be a positive. It's the same number. Do y'all see what I mean? And so you may wonder, well, then why wouldn't I just always use one or the other? It kind of depends on, you'll see as time goes by, what's in the rest of the problem. If for some reason I need an n minus 1 in the problem anyway, to make my numbers go like 0, 1, 2, 3, it kind of makes sense to be a little consistent in the formula. It just looks better to people, but it doesn't have to go that way. So I'll read what you wrote, and if you come up with something that works, then I'll give you credit for it. All right, so if it alternates, oh, I'm sorry, let me pause. Somebody had a hand up that I just ignored completely. Isabel?
Well, we could do this later, but I was just wondering if we could do like sequences with factorials.
Uh-huh. That is on my list of things to do. And I'm going to answer homework questions in a little while. But I'm just kind of getting started, so when I answer some of the ones you struggle with homework, it'll make more sense, okay? So multiplying by a negative 1 to some power is going to make your signs alternate. That'll make it go positive, negative, positive, negative, positive, negative, okay? Multiplying by it. And then if you want it to be a multiple of something, you multiply some number in there, okay? If I want it to be multiples of 2, I'll put a 2 in there. So if you're having multiples, you want to be multiplying, okay? If things are going like we had 2, 4, 2, 4 the other day, if they're the signs are not alternating but the numbers are alternating, you want to add by a negative 1 to the n power, and you will add a number to it. Let me show you what I mean. Suppose this is going 2, negative 4, 8, negative 16. First of all, you're multiplying by 2, right? All right, but also, do you see my signs are alternating over here? I'll scroll up a bit. I don't want to go too far, but I want to really talk about all this multiplying, continue to multiply, adding, continue to add. On this one, what I would do is I would say negative 1 to the n power, and then I can make it multiples of 2 by going 2 to the n power. And then play around with it and make it work. If n is 1, okay, what is 2 to the first? 2, but what is negative 1 to the first? Negative. And so do you see I can play around with a little bit and make it work for me? But y'all see how I stuck this 2 to the n and I multiplied by it? Let's go forward. Let's go if n is 2. If n is 2, what's 2 squared? 4. And this is negative 1 to the third, so that'll make it negative 4. Do you see it's working? So that's all multiplication. I'm multiplying, I'm multiplying, I'm multiplying. All right, this one, when it's switching back and forth from number to number, okay, I'm going to use a negative 1 to the n power. And in this case, I'm going to add it to 3. Because isn't 3 right in the middle of 2 and 4? I want to add 1, subtract 1, add 1, subtract 1. We'll do a harder one in a minute. I think there was maybe a harder one in your homework. Now, if n is 1, will my first number be 2? But do you see how these are alternating? And when it's alternating, you'll add, okay? If the signs are not alternating, but the numbers are alternating, you'll add. Hopefully that makes sense to you. You want to go plus, minus. You want to go up above it, down below it, up above it, down below it. So let's look at this one. So what if I have 5, 9, 5, 9, 5, 9? I go, oh, I'm going to need a negative 1 to the n power, okay? What's right in the middle of 5 and 9? 7. All right, but I have a problem. I'm only going to go 7 minus 1, 7 plus 1. I need to go 7 minus 2, 7 plus 2. Will this work? All right, so I give you like the only thing a teacher can give you really, because you've got to think, which is great to do at this level. It's not like when you're in Algebra 2 and I could just give you a list of stuff to learn about quadratics. I don't know what series that you and I are going to have to write, okay? I don't know what delta math's going to throw you, because you all get different questions. So you got to think on your feet, but you have some basics that you go to, okay? I think it's just like in training, you know, like they couldn't have told me everything I was ever going to face as a teacher. I can promise you. In the first week, I realized that they had not told me near everything I was going to need to know as a teacher. But I was glad for the training that I had in math, not only in education. But anyway, that's exciting. Now will this work? If n is 1, that'll be 7 minus 2. What if n is 2? What's negative 1 squared? Positive 1 times 2. That'll work, won't it? Okay, so do you see that you've got to finagle it, okay? You've got to play around with it. But if you're wanting to go back and forth from a number, use negative 1 and add it. If you have multiples of a number, multiply, okay? And then I'll get specific questions. Don't forget if you have something like this, 23, 25, 27, that's arithmetic. And I'm adding by 2, so I have a 2n. If n is 1, and by the way, n might not always start at 1. Right now, you don't know why. It is not your concern. Somebody will tell you, okay? If n is 0, I've got to be careful. Sometimes I have series in calculus where n starts at 2. And there's reasons for that I'm not going to get into today, okay? But I believe you trust me on that with everything I've proven to you this year. But now I've got like the basics down, and I've got to make this start at 23. So wouldn't I add 21? And then you can try a few and see if that's working. If you're multiplying by 2, 8 times 2 is 16, times 2 is 32, times 2 is 64. I'm going to have a 2 to the n power. Common sense tells me that, girls, which we're going to get into a little bit more today. Multiply by 2. This is 8 times 2 is 16. Then, didn't I take 8 times 2 times 2? And I got 32. And then 8 times 2 times 2 times another 2. Do you see where the exponent's coming from? By the way, I really need to tie in when I teach you geometric, which may not be today. They're exponential. You can already see the exponential growth, can't you? You studied exponents a bit, I hope, in Algebra 2, where they grow exponentially. If you have a power, they'll grow exponentially. What will arithmetic be? Very good. Woo-hoo. They'll be linear. Very, very good. If you're going to write that down, arithmetic or linear, because Pietro, that's awesome. You have a slope, don't you? Aren't you going up 3 or up 2 every time? Okay, or down? Arithmetics are linear and geometrics are exponential. Awesome. Okay. And then you're going to be shocked at some of the other stuff, okay? And that's really cool. But those are the two, definites that I can give you, okay? The other thing we talked about is if you had 4 plus 3 is, let's go 4 plus 1 is 5. 5 plus 3 is 8. I think you know where I'm headed with this. 8 plus 5 is 13. 13 plus 7, do you see my pattern, is 20. What are you going to definitely use if it's going 1, 3, 5, 7? Not just exponents. What goes 1, 3, 5, 7? All right, let's write them. 1, 4. I'm trying to think back here if I need to get rid of this one. I'm going to leave it there for now. 1, 4, 9, 16. This is 3. This is 5. This is 7. So I'm going to use squares. Like this one would just be n squared. Okay? So this one is going to be n squared. I'm not sure. I'm trying to think. I think I can get that one. If n is 1, I get 4. If n is 2, I get 7. Yeah, I can't start with 1. Sorry. I probably could, but it wouldn't show you. I would have to do something different. So what you'll see is 3, 5, 7. So you'll have n squared if it skips by 3, 5, 7. And then you've got to make it work. If n is 1, you'll need plus 4. If n is 2, will this work still? If n is 3, it's working, isn't it?
Yeah.
So you get your meat of your problem and then you adjust it. You're doing transformations. Do y'all see that? You're really sliding it around with transformations, if that helps. Okay? Okay, so now let me take specific questions or specific homework questions. If there's a notation you didn't know how to handle, something about factorials. Grace?
It was number 75, the very last one, and it was
Number what?
75.
Okay. All right, 75 is 2n minus 1 factorial over 2n plus 1 factorial. I'll start doing this semester. When I had my own classroom, I had whiteboards all over the room. And on one board, it was probably written there so long, they probably still can't erase it, okay? It's probably still stuck there for Dr. Who, I can't say her last name, she's a good friend of mine, that took my place. Or, but she didn't take my place, she's amazing. Anyway, my shoes were definitely not too big to fill. But what I would tell my students is be very, very literal, okay? Why I say that in calculus is all of a sudden you'll see, and AP, you'll tend to freeze up and go, oh gosh, it's so weird, it's so different. It's got N's and A's and B's and whatever. And I tell my students, just calm down. I'm not going to give you something I hadn't taught you how to do. So how are you doing it if I said 83 factorial over 81 factorial the other day? You started writing it out, right? Let's start writing it out. I've done this with a couple of people, okay? So I'm just going to calm down and go, well, this looks really weird, but let's see what happens. 2n minus 1, what would the next one be? 2n minus 2, 2n minus 3. This is also a good standardized test, mostly for the SAT, not ACT, which I think for some of y'all is coming up this weekend. But it's a good skill for SAT also. Just start writing it out. Girls, if you think something has a pattern, start writing it out, and one of two things will happen. If you're having to write out a lot of it, you're going the wrong direction. If you find out you're writing 200 numbers out, okay, during that time, you probably should notice a pattern with the first few things that you do. I'm not going to keep doing that. It'll never end. On the bottom, I have 2n plus 1. What's the next one?
2n plus 2.
Careful, it's going down. 2n, 2n minus 1, 2n minus 2, dot, dot, dot.
So the rest of them.
They're all subtract 1, don't you? 5, 4, 3, 2, 1. Okay, good question. So they're all subtracting 1. Like I said, girls, look, I'm being very literal. I'm going, I know what factorial means. This looks weird to me, but I'm just going to start subtracting 1, okay? And then this cancels out, and I have 1 over 2n plus 1 times 2n, which is 1 over 4n squared plus 2n. And I don't know if they had the answer in the back or what it looked like. What did it look like on the, anybody check?
It was 2n times 2n plus 1.
Okay, so the first one.
Over, like, under 1.
Okay. So they left it like the first one.
Yeah.
Which is pretty normal with a factorial. They leave it sort of factored. Okay? The reason that Grace, and some of you others that I've done this one with, the reason you may wonder, why didn't they just give me a number? You'll see, as time goes on, if I ran into that a lot, which you may wonder, how in the world could that ever happen to me? If I ran into that expression a lot, I could go straight to this, the number of terms every time. If I knew that this had 100 terms, I could just fill 100 in for n instead of fight with this. Okay? And you don't have to fight with that a whole lot, but you'll see as time goes on. Okay? All right, so great question. I would not hesitate to put something like that on a quiz or a test. So if you didn't quite get that, see me or ask again. All right, other questions? All right, Lauren? All right, 49. All right, 49 is 1, 1/2, 1/6, 1/20. Oh, good, Lauren. 1 over 120. Girls, by the way, remember our words? These are sequences. These are sequences, these are not series, okay? They'd be series if I was adding them together and they'd actually equal a number, okay? I don't know how you could really notice this until I tell you. I've told a couple of people already. And thank you for really doing your homework because this is a great question, okay? And I'm guessing the way I do homework checks, you checked it or looked in the back of the book and you're still like, how did they know that? You need to learn to start to recognize, just like you recognize perfect squares. Like if I say 144, you should know that the square root of that is 12. There's certain things in math that you notice, like 7 times 8 is 56, okay? You should not have noticed this yet, so don't panic, but you should notice this from now on, especially as we get, again, I expect my BC students to recognize these. 1 factorial is 1. 2 factorial is 2 times 1, 2. 3 factorial is 3 times 2 times 1 is 6. 4 factorial, can I stop this and just multiply by 4? I'm just tacking on another number. 4 times 3 times 2 times 1. 5 factorial is 120. 6 factorial is 720. That's about as high as I have memorized, but I notice them. That's all I need to be able to do. I actually could figure out 7 factorial, but I recognize those. I'm like, oh my gosh, that's 5 factorial. You shouldn't yet, but you should from now on. You should as of 2 seconds ago. Recognize your factorials, or Lauren, that's a great question. You had to really play around with this. I think some of y'all may have started going, wait, this is 2 times 1, this is 2 times 3, but whether you would have realized that's 2 times 3 times 4, I don't know if you'd have noticed that, okay? I probably wouldn't have unless somebody told me. Now you should know it. So this is 1 over n factorial, as long as n is starting at 1. N might not always start at 1, but I think it would, we were assuming, yeah. Did y'all notice that? You probably maybe didn't in your homework. Assume n starts with 1. Sometimes I need n to start with 0 because I've told you need that initial amount before time starts clicking, okay? I might have, start counting like who has the flu, and I might already have 8 cases. And that's my initial amount, and after a day, I want to see, my first day, how many people have it. I shouldn't have used the flu. I just use horrible examples, like people are dying and getting sick. But, so we have 8 puppies, and
Then we have 2 that are pregnant.
and there's more puppies. So the next year I see how many are. I don't know how long it takes to have a puppy. Okay, anyway, I tried to make that better. I should know. My dogs have had puppies. But anyway, don't remember. And my cats have had kittens. I don't know how long it took. Okay, so funny story. When my cat, Finn, was pregnant, if you have a cat, and I sound like a cat person, I'm really not, but I like animals, but I'm not crazy about them. But I love my animals. But my cat was crazy, and she was pregnant, and I was writing a paper for my master's program at the kitchen table, gotten all my kids to sleep, and I had peace and quiet, and apparently the kittens were due because she was on my paper that I was trying to write, looking at me going, like screaming. I'm like, I can't help you here. So I would take her back to the little like cushions and towels I had put down for her in my closet, and 13 seconds later she was back, like, screaming. She finally had them, but that's an even funnier story. I was going to the beach the next day, which is why I wanted to get my papers graded. So she's still having kittens when it's time to go to the beach. So I put her in the box with her kittens she had. There were still more. And I had to call them a couple of days later to go, how many kittens are there? So then there's another story to that I'll tell you next time. All right, so anyway, your cat can have kittens for an extended time in case you, or my crazy cat can. All right, so back to puppies and the flu. So factorial, look at it, let it sink in. If you don't recognize it again next time, you'll recognize it again the next time. You've got time to get that done, okay? All right, any other homework questions? Those are ones I expected. That's great. Okay. Don't be too quick to look at the answer. Because then you've got to make sure that your brain would have thought of it. Sometimes you got to give up and look at the answer. I definitely want you to check your answers, okay? There was one, what was that one, Isabella, that I was doing with that -2?
62.
Oh, 62. Oh, thank you. I wanted to do some recursive anyway. 62 is a sub 1 equals 14, and a sub k plus 1 equals -2 a sub k. In fact, girls, you can't do recursive unless I give you one or two terms. It's impossible to do recursive unless somebody gives you one or two terms, because then you don't even have any idea where to start, okay? Like, for instance, if I'm looking for a sub 2, if k is 2, then what is k plus 1? It's a sub 3, and this means I don't really know what the term is. It's where the term is. So I can't find a sub 3 unless I know a sub 2 and so on. So we have to give you some information. All right, now, if I say that list the first 5 terms, at least you have one of them, okay? So don't miss that. A sub 2, a sub 3, a sub 4, a sub 5. These are like what I call composite functions. They're called recursive, where you have this information. So now I'm looking for a sub 2. So right now, k plus 1 is 2. So what is k? If k plus 1 is 2, what is k? Wouldn't k have to be 1 in that scenario? And so if I want a sub 2, I'm going to have -2 times a sub 1. Like what I'm saying is if this is 1, isn't that a 2? All right, now can you work a sub 2? It's -2. What is a sub 1? 14. And so I get -28. Now, what happens if k sub 1 is 3? I'm looking for a sub k plus 1. Careful. If k plus 1 is 3, what is k? 2. So if I'm looking for a sub k plus 1 equals -2 times a sub k, if I have a sub 2, that enables me to find a sub 3. Do y'all see what I mean? So k plus 1 means you're finding the next one. All right, so you probably can move a little faster. Do y'all see you're going to have to multiply -2 times the term before it? And I know you're not used to seeing these, but you'll get used to it. You'll be able to read that a little better later. If this is k and this is k plus 1, it means to get the next term, you need the one before it. If it's k minus 1, it's the other way around. All right, if I multiply this by -2, I get 56 and negative, what'd you get?
112.
And,
2.
oh, well, I could multiply that by 2. I'm sorry, I don't know where my brain went. Okay. Anyway, now I think it told you to write an explicit formula for it use a pattern to write the nth term. Okay, girls, you're going to be in a world of hurt on the test if you don't learn this right here, okay? Because after I give you a recursive one, many times I'll then say, what is a of 49? You could get there, but it's going to take you a long time, right? Because what are you going to need for a sub 49? 48, okay? So you want desperately to be able to try to rewrite this explicitly rather than recursively. All right, so what's happening? What's happening? It's alternating, so I need a -1 to the n. I'm also multiplying by 2. And so let's see what I have so far for any term, a sub n. My first term would be -2. What would my second term be? My first term would be -2. My second term, what would my second term be? +2. What would my third term be? -2. So at least I got the alternating part down, but I don't have the other stuff going, okay? But how am I going to start with 14? Oh, by the way, aren't my signs alternating in the wrong way? My signs are going negative, positive, negative. I want it to go. So I'm going to make this n plus 1, and won't it change these? Now, how do I make this start with a 14?
The
Add 14.
I put 14. And I'll split by 14.
I was going to say I've got to multiply it by 7. 7 times 2 is 14. But that's not going to work. That's why I didn't want to throw a 14 in there. All that's going to do is make 14 alternate. So let me talk you through how I did this. I knew it had to alternate signs. And so I said a sub n is equal to negative 1 to the n plus 1 to make it start with a positive. Then I wanted to multiply by 2, so I have 2 to the n based on the concepts I've said in class a couple of times. I'm multiplying by 2, so I need a 2 to the n. But I need to start with 14, and these are all multiples of 7. So if I go 7 times 2 to the first, won't it start with 14? Do you see how I multiplied again if it's being multiplied by something? Let's see if it works. What's a sub 1? 7 times 2 times negative 1 squared. Is that 14? A sub 2 is 7 times 4 times negative 1 to the third. Is that negative 28? Did y'all see that's working?
Yeah.
Probably not what they had in the back of the book. I'll talk about that. But that's acceptable. That pattern works because I went through. It's alternating. It's being multiplied by 2. And the only way to start with a 14, I had to multiply by 7 to start with 14. There's other ones you could write that are correct. Now that I have it, remember my process. It was alternating, multiplying by 2, and I wanted to make it start with 7. If there were multiples of 5, I'd have a 5 in there, okay? You can also do some algebra. You can say 7 times 2 to the n. This is negative 1 to the n times negative 1 to the first. Let me pause for a minute. We'll do this in calculus also. You're used to going from this direction, girls, to that direction, okay? If things are multiplied with the same base, don't you add the exponents? But you'll have to start noticing in pre-cal and calculus, what if the exponents are added? Oh gosh, those must have been multiplied, okay? And now if you have the same power, you could just call that negative 2 to the n, which some of you may have wanted to do. So if I have 7 times negative 2 to the n, then I still need this though. Negative 1 to the first is negative 1. I myself would have just written it like this. But let's see if this works. If I fill in 1, oh, you could just say negative 7. Is that what y'all were saying?
I was saying my one was 14 times negative, in parentheses, negative 2 to the n
N minus 1. That also works. N minus 1 makes it start right at 14. And so, like I said, there's all sorts of different ones. This one's going to be negative 7 times negative 2 to the n. That one also works. It'll give you 14 at the beginning. So I would accept this one, this one, this one, or one other one that you might come up with. Okay? All right. You've got to make your mind think through this or you're not going to get it. But I'm not worried about you because you've already had to make your mind think through an awful lot of stuff. It's a bit unsettling when it seems like, what am I going to do when I encounter something? So I want to give you as many handles as I can. All right, now, let's go to, oh, by the way, I threw this at you in the last class. 0 factorial is defined to be 1. It's just like the square root of negative 1 was defined to be I, and it opened up a whole new operating system. And so this is our operator. You haven't studied other operating systems yet. You just worked with the integers. And so you're kind of not used to that. But to make something work, you need to define a few things. There's a proof of that I'm not going to get into because I want to move on. Okay, now let me get you used to, if you don't already know, summation notation. It's beautiful. All of a sudden, you start to feel like, you know, if I pull up a commercial or a picture of like Einstein, or you watch Big Bang Theory and there's all that stuff on the whiteboard, you're now that person. You're becoming that person. You see sigmas behind them, which actually turn in later into these. So sigma is a symbol that people use. It's a Greek S, and it means take the sum. Some of you may have done this. A German mathematician that I don't know if I ever say his name right, Leibniz. He was German, so he used a German S, okay? These both mean sum, but you also see these behind smart people like floating around in the air. Now, if you stop to read them, I actually sometimes have Paul's Big Bang Theory and work the problem. One time I worked it faster than they did. There was some competition between Leonard and what's the Sheldon. There was an integral that he had given Leonard to work, which he did work, but you can work it a lot easier than he did. But that wasn't part of the show. Anyway, be that as it may. You're now that person. All right, so sigma is a beautiful notation. If I want you to, well, here, let's just do one. If you have this notation, unfortunately, our book uses I's instead of N's and K's sometimes. I won't ever do that to you. It's not it's not the imaginary number. So I feel like they shouldn't do it, but engineers use it a lot in electrical engineering. So, we are not in the complex numbers right now. It's just a counter, something to count with. As K or I, this one says as it goes from 1 to 5. So you may have done this, but I'm going to pretend like you haven't, okay? What that means to do is start by filling in I is 1, 3 times 1 is 3, okay? And you go all the way, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, and 3 times 5 is 15. You did it. Do you see it tells you what integer to start with and what integer to stop with? Okay. Now let's use our other notation. What is a sub 1? 3. What is a sub 2? 6. Do you see how I have those subscripts? Please, on your homework, watch where this starts. They could start at 0. They could start at 5 if they want to, because there's a reason that they're starting where they're starting that you don't need to worry about right now. Okay? Now, do you see I'm really not finished because I actually should do what with these numbers? Add them together. It ends up being 45. There's an actual way to punch this into your calculator that I don't really mind, but remind me to show you that later. I don't want to get into it right now, okay? It's nice to know if you got to add up 500 of them. It'd be really nice to use your calculator, but we'll do that later. You don't need it right now. Nicole?
Can I show you a funny meme about like the Big Bang Theory that you just said, but like kind of different?
Yeah.
It's like,
You should send it to me. We could
you
do
know you're
something.
not a kid anymore when you're watching High School Musical and understand what Gabriella's doing on the board.
Oh, that's
It's like,
awesome. Yeah.
oh, why
that's
she do
good.
those boards? I think probably
She's
she's
balancing the
Oh,
equation.
I'm the way I saw like
You said on it.
She's doing the oxidation numbers.
All right, look at this one.
Actually though.
Thanks. That's what I'm talking about. We're not going to do all of these, girls, because I don't think you need a lot of explanation, but I don't want you to all of a sudden look at your homework and not having seen this before, okay? This one, you notice where to start. You're going to fill in 3, 4, 5, and 6. Okay? Y'all see the k squared? I would expect something interesting to happen. Let's do this one. If I fill in 3, I get 10. And you write plus. We're now in series. If I fill in 3, if I fill in 4, I believe I get 17. If I fill in 5, I get 26. And if I fill in 6, I get 37. Of course, what did these skip by? 7? I'm sorry, that's 37. Did y'all see they skipped because it was quadratic by 7, 9, 11? If you could read my writing, they're doing that. I would expect something like that to happen, okay? Now, in our class sum and in calculus, we spend some time having to write that as be able to write this as this, which you're pretty able to do based on last night's homework. Let's see, so you'll run into those. Now, some things that you're allowed to do. This is super important. Sigma is very permissive, which is actually wonderful news. Okay? Is sine easy to deal with? Can I just go, oh, I just don't really like that 2 there, so I'll just pull it out. Obviously, you can tell by the tone of my voice, you better not do that, right? Hopefully, I knew that anyway. That's apples and oranges, isn't it? This is affecting the period. This is affecting the amplitude. This is double an angle and then take the sine of it, not take the sine of an angle and then double the answer. No, you cannot do that, okay? Aren't y'all kind of used to that? Like, can I take out this 2? Can I make that just the logarithm of A times the logarithm of B? You better not, okay? So there's so many things you can't do that you wish you could do. Here's a good one. Don't you wish you could just go cosine A plus cosine B? But that's not at all what it's asking you to do. It's asking you to add 2 angles and take the cosine of it. We had this long proof that showed us this crazy identity. Okay? Here's the good news. Sigmas are really easy to deal with because you can do the things you wish you could do. All right? Like, for instance, if I have the sum of 3n as n goes from 1 to 4, I can make this 3 times the sum of n as n goes from 1 to 4. Do you see how I factored that out there? Because why would I stop and go 3 times 1, 3 times 2, 3 times 3, 3 times 4? Isn't that factored out 3 times 1 plus 2 plus 3 plus 4? So you're allowed to do this, which might make your life a little easier, especially when we learn Gauss's formulas, which we're not going to do today. That's like major news. You can do that, okay? If you have the sum, and all of this, by the way, these little skills I'm giving you are at the bottom of page 574. If you have the sum of A plus B as n goes from wherever, I'm just going to go 1 to, it doesn't matter where we're going to, we'll go 1 to n. Oh, I'll go 1 to k. So I need another variable. Anyway, what I'm trying to tell you, if you want to, you can make this the sum of A plus the sum of B. Where normally I would be like slapping your hand, okay? Well, like if you have the logarithm of A plus B and you try to go logarithm of A plus logarithm of B, I'm going, no, don't do that. Do you see how sigmas are really nice? You can do that, okay? You can distribute them, you can factor out of them, and do them piecemeal if it helps you. All of these skills are good to know. All right, now, what is the answer to this? What's the first term? What's the second term? It's a constant. You're used to 7n and it changes as n changes. Right now this is not changing. So how many 7s will you have?
10.
So what do you get if you add them all together? Remember, these are sums. So the first term is 7. The second term is 7. All the way out to the 10th term is 7. So girls, the quick way to do this is just multiply. You're going to have 10 of them. But be really careful where it starts. Do you see that could mess you up? So just watch for that. If it starts at 1, you can just say your constant times however many you have. If you feel like writing them all down, you can. Okay? All right, now...
If it starts at 2, then wouldn't it?
what? If it started at 2,
Yeah.
then you would have how many 7s?
Oh, you just have. You have 1 less, so it would be.
You've got to subtract and add 1. Hey girls, let's be quiet. These are super important questions, and you may be missing something. There's 10 terms here because 1 is included, right? 1, 2, 3, 4. So you can subtract when they change on you, but you better add 1 for the one you start with. 10 minus 1 is 9, plus 1 gives you 10 terms. I was afraid some of you might think there's only 8 of these 7s right here, okay? But there's really 9 of those. 2, 3, 4, 5, 6, 7, 8, 9, 10. You don't want you're in a position having to count on your fingers though on the days that later on that I might go 4 to 100. I know there's 37 terms on that, okay? You subtract and add 1 because you better count that initial term, okay? All right, now look at this one. This one's super duper interesting, and I kind of got us here the other day. Okay, look at this one. Okay, girls. This would be like, not just Grace Hooper's question, but questions that some of you came in with this morning with the 2n minus 1 factorial over whatever. Like, what? I would say just start doing it and see what happens if you see this in homework, because you hopefully will notice something before you get to infinity. All right? So here, I get 3 over 10. Then I get 3 over 100. Then I get 3 over 1,000. Then I get 3 over 10,000. And I keep on going, and I'm supposed to add all of these up, girls. Listen, I'm not supposed to just write them. I'm also then supposed to add them all up. So remember how I talked about the other day, we do some really weird Twilight Zone stuff. I'm about to add up an infinite amount of numbers, so are you. Does anybody know the answer yet? Is this one 0.3? Is this one 0.03? 0.003.
1/3.
Thank you, Miss Arcan. So it's 0.3 repeating. So all of that adds up to 1/3. We just added up an infinite amount of numbers.
And they couldn't just write 1/3.
They could, Nicole, but obviously we're headed somewhere insane with this stuff, okay? Or phenomenal, okay? All right? So look around as you're doing things. Okay, now let me show you this real quickly. And I'm keeping an eye on the time. I have 2 wonderful minutes to get this done. All right, so I'm going to write down the sum. Girls, be quiet. As n goes from 0 to 7 of negative 1 to the n over 2n plus 1 factorial with an x next to it. Okay? Now, this could happen to you. It won't happen in tonight's homework, but be very literal. Please stay with me. You don't even have to write this down. This is for your viewing pleasure right now, okay? If I have negative 1 to the 0, I get 1. X on the top. Be quiet and hold still. I should have said you had to write it down over 1 factorial. Then if I fill in 1 times negative 1 to the n, I can't read my writing anymore. Quiet. Grace, be quiet. If I have negative 1 to the first, I get a negative. And I get, I'm sorry, this should be x to the n plus 2n plus 1. So this becomes x to the third over 3 factorial. If you continue with me, you get x to the 5 over 5 factorial. It'll just do this. If you do a few, you've got the pattern. Okay? Watch this. Watch what happens. All right, watch the screen. X minus x cubed over 3 factorial plus, it's alternating, x to the 5th divided by, 5 factorial minus x to the 7th divided by 7 factorial, couple more, plus x to the 9th divided by 9 factorial. See what's happening? Girls, look. Turn off the red. Turn on the red. What would happen if I take the top polynomial?
It's gonna keep following us.
Yeah, if I go dot, dot, dot to that top one, that's a polynomial that is exactly sin x.
Wait, that's so cool.
Earth shattering. Goodbye.
Look at it.
Have a nice weekend. If I look at it.